Hello again. This is Roger Kochbar for the Bioelectricity course. This is for week 1, lecture 12. And I thought for this lecture it might be worthwhile to take a few minutes and talk about the first week in review. This has been a busy week. It began with a discussion of Galvani and Volta. They argued about whether animal electricity was a distinct, fundamentally different phenomenon, as Galvani thought, or whether, as Volta thought, it was all the same thing in different forms. Well, as we now look back on it, we'd say Galvani was wrong. Electricity in solutions and electricity in living tissue is fundamentally the same thing. On the other hand, we would say, well, actually, Galvani was right in the sense that the phenomenon may be the same in its fundamentals, but in bioelectricity, the manifestations and the computational rules are different, and many of the practicalities are entirely different. And we could use as an example here the comparison of the battery versus the stingray when put into ocean water. If we think about ocean water, we can think about why is it conductive. Pure water is not very conductive at all. It's almost an insulator. So solutions, water and others, get their conductivity from ions. Ions are dissolved particles, such as dissolved sodium chloride, that have ions, and these ions can move around and give solutions their conductivity. We looked at some particular numbers, and we looked a little more carefully at the combination RT over F. It's strange that it shows up so frequently in bioelectricity, but as it does, it's good to remember that its value is 26 millivolts, more or less, with the variation coming because T, the temperature, varies somewhat from one circumstance to another. In the most technically complex topic for the week, we talked about electricity in solutions in terms of the Big Five: potential, electric field, mechanical forces, current or current density, and sources. And we noted that each one can be computed for the others. So actually, if you know any one of them at every point in space, you can compute all of the rest. An amazing circle. And finally, we noted in anticipation that in bioelectricity, some numbers are small, but other numbers are big. And in particular, they're big electric fields, and they're big forces that go across biological membranes. If you look at these 6 conclusions for the week as a whole, you'd say, wow, it's been a busy week. Well, yes, it has, and this is very good preparation. But the exciting part is yet to come. We haven't really yet talked about bioelectricity. So as we say goodbye to our 2 guys, we'd look at this picture and say, yes, it is true that computer in the picture, right there, that's a very modern and complicated device. But the really complicated devices in this picture are these 2, this unit and this unit. Whether you count in terms of parts, complexity, integration, sophisticated combined function, this is where bioelectricity really does its thing. Thank you for watching. Come back and see some more in week 2.